Hi ladies and gentlemen, this is Mr. Green and this is another in my series of lessons for pre-cal. What we're going to be looking at today is lesson 4.3. 4.3 is just the application of identities is all it really is. It covers a couple of new identities, but it's still just the application of identities, okay? So, due dates, remember those are out there. You need to be aware that they're out there and make certain you don't leave any zeros in your grade book. So, what we're going to do is not make this any harder than it has to be. Get that formula chart out, print it out, keep it there by what you're doing, okay? You'll need to use those formulas over and over again. So, here's a problem. It says the horizontal distance traveled by a projectile. It says find the initial angle theta and the initial velocity of 60 meters per second can be modeled by this equation right here. And it says choose the angle that would make this information give you the maximum distance. Is what it's asking for. Okay. So what I did was I said, well, I recognize that I've got sine A times cosine A. Right? See, theta. Sine theta times cosine theta. Where A and B are equal to each other. So I wrote down that identity, 1/2 sine A plus B plus sine A minus B. So when A is equal to B, that turns out to be 1/2 of sine 2A plus the sine of 0. So, when you take the sine of 0, you get 0. So basically, this sine of 2A is going to be a maximum at pi over 2. So 2a is going to have to be pi over 2. So 2a equals pi over 2. Divide through by the 2, and I get that a is equal to pi over 4. So 1/2 of pi over 2, which is what we're looking for here, right? If I stick a pi over 4 into a, I get pi over 2 there. So 1/2 of that is equal to 1/2, because pi over 2, sine of pi over 2 is 1. So that equals 1/2. So my maximum distance is going to be 7,200 divided by 9.8 times 1/2, or divided by another 2 there. That equals 367.34 feet. That's how you use this identity to help you in this situation. I used this identity because that was what this was equal to. Okay? Going forward. So I've got this. 12 times sine x cosine x is equal to 3 over 12. And they want me to come up with the values for x in this situation. So I just wrote that down, and then I said, I'm going to divide through by the 12. That's going to give me sine x times cosine x is equal to square root of 2 over 4. So write down the identity of sine A times cosine A. I'm going to have this, where A is equal to B, and I'm going to get 1/2 of sine x plus x plus the sine of x minus x is equal to this value. Well, this is 0. That's going to be 0 right there, right? So I've got 1/2 of sine 2x is equal to pi over 2. Well, that means the sine of 2x is equal to pi over 2. I'm square root of 2 over 2. So that means that the square root of x is equal to pi over 4, because that's when you get square root of 2 over 2. So it also means that it's equal to 2x is equal to 5 pi over 4. Dividing through by the 2, I'm going to get pi over 8, and then every n pi thereafter. Okay? And 5 pi over 8, and every 5 pi over 8 plus n pi thereafter. So it's occurring twice every sine curve that there is. Okay? Because sine goes up, down, and up, and there's a 2 pi, period. Right? So to get square root of 2 over 2, it's occurring twice here. Right? And that's what we'd be looking for. Okay, moving forward. Make certain if you have any questions about how to apply these identities that you're sending me your K-mails. I will be trying to read them in the evenings and try to get back to you as quickly as I can. I look forward to seeing you next time I can. We will not have a class connect this week, but we will get to you as quickly as we possibly can. I'll talk to you next